In this session, you will study in detail about nucleophilic substitution reactions SN1 and SN2. The mechanism of both the reactions will be explained to you. So let us start with the SN2 reaction. What is an SN2 reaction? The term SN2 stands for substitution nucleophilic bimolecular reaction. In this reaction, when an alkyl halide interacts with the nucleophile, the bond between carbon and halogen present in the haloalkane breaks. Simultaneously, a new bond will be formed between that carbon and the nucleophile. That is, the breaking of bond and the making of bond take place simultaneously in a single step and no intermediate is formed. Therefore, we can say that the reaction takes place in one step. It follows second order kinetics. That means the rate of the reaction depends upon the concentration of both the alkyl halide and the nucleophile. It is a bimolecular reaction. What is the order of SN2 reaction? It is second order. Now, what is meant by a second order reaction? Second order reaction means the rate of the reaction will depend upon the concentration of both the alkyl halide and the nucleophile. Let this equation represent SN2 reaction given by methyl chloride. The carbon halogen bond in haloalkane is polar with carbon forming the positive end and halogen forming the negative end. Here, the nucleophile attacks the carbon carrying the halogen atom from an opposite side. Now, as the reaction progresses, the bond between the nucleophile and the carbon atom starts forming, while the bond between carbon atom and the halogen atom weakens. As this happens, the three CH bonds of the methyl group starts moving away from the attacking nucleophile. As a result, configuration is inverted. So, SN2 reaction leads to inversion of configuration. Now, another important point is that in the transition state, carbon atom is found to be bonded to 5 atoms or group of atoms. Such structures are highly unstable and cannot be isolated. Here you can see backside attack of the nucleophile, formation of transition state and inversion of configuration. Backside attack of hydroxide ion on the haloalkane with the formation of alcohol and halide ion. Reactivity of alkyl halides towards SN2 reaction. Next, we have to know out of primary, secondary and tertiary alkyl halide, which one will be most reactive towards SN2 reaction and why. Consider the compounds given. The first compound given is methyl chloride. Then we have ethyl chloride, and you know it is a primary alkyl halide. Next compound given is isopropyl chloride, which is a secondary alkyl halide. And the last compound given is tertiary butyl chloride, which is a tertiary alkyl halide. You know that in SN2 reaction, there is backside attack of nucleophile on the carbon carrying the halogen atom. That is, if less number of bulky groups or if less number of larger alkyl groups are present around carbon carrying the halogen atom, the nucleophile can easily attack that carbon. Among the compounds given, methyl chloride has only 3 hydrogen atoms around it. So, steric hindrance is very much less in the case of methyl chloride. Ethyl chloride has 1 methyl group, isopropyl chloride has 2 methyl groups and tertiary butyl chloride has 3 methyl groups. So, in which compound do you find more number of bulky alkyl groups? In tertiary butyl chloride. So, steric hindrance is more in tertiary butyl chloride. Since steric hindrance is more in the case of tertiary butyl chloride, the nucleophile cannot easily attack the carbon carrying the halogen atom from an opposite side in the case of tertiary butyl chloride. Therefore, tertiary butyl chloride is the least reactive towards SN2 reaction. Out of these compounds given, methyl chloride will be most reactive towards SN2 reaction since the steric hindrance is very much less in the case of methyl chloride. Consider ethyl chloride. You know that it is a primary alkyl halide. See, the carbon carrying the chlorine atom has only one methyl group attached to it. Now take isopropyl chloride. It is a secondary alkyl halide. See that the carbon carrying the halogen atom has two methyl groups attached to it. Next, consider tertiary butyl chloride, which is a tertiary alkyl halide. The carbon carrying the chlorine atom has three methyl groups attached to it. So there is greater steric hindrance in the case of tertiary butyl chloride due to the presence of more number of alkyl groups. So tertiary butyl chloride will be least reactive towards SN2, whereas primary alkyl halide will be most reactive because the steric hindrance is very much less. So what is the order of reactivity of alkyl halides towards SN2 reaction? Primary greater than, secondary greater than tertiary. Or we can say that primary alkyl halide is the most reactive towards SN2 reaction. Consider the compounds ethyl iodide, ethyl bromide, ethyl chloride and ethyl fluoride. Out of these compounds, which is most reactive towards SN2 and why? Ethyl iodide is the most reactive. It is because due to the large size of iodine atom, it is a better leaving group. So ethyl iodide is the most reactive. Or in general, we can say that alkyl iodides are the most reactive towards SN2 reaction. It is because due to the large size of iodine atom, it is a better leaving group. Reaction at a glance. Substitution nucleophilic bimolecular. Second order kinetics. Rate depends on the concentration of both the alkyl halide and nucleophile. Molecularity is 2. Takes place in single step. Backside attack of nucleophile leads to inversion of configuration. The order of reactivity is primary alkyl halide greater than, secondary greater than tertiary. It is because less steric hindrance in primary alkyl halide. Alkyl iodides are most reactive. Iodine, due to the large size, is a better leaving group. Consider the equation. This is how you write the equation for SN2 reaction.